Okay, so yesterday we talked, or you watched videos and notes on different types of angle relationships and parallel lines cut by a transversal. Today we're going to use those to solve some problems and prove. So, for the first one, there's this theorem that says that if corresponding angles are congruent, then the lines are parallel. So we're going to use that then to answer this question. These are corresponding angles. This angle right here and this angle right here are corresponding, which means if they're the same, then M and N would be parallel. So to make them the same, we set them equal. And then solve this. So take away 5 from both sides, divide by 3. So we would get that x is 20, and that's the value that makes M parallel to line N. Okay, so they have to be congruent when they are corresponding angles. All right, so here's a few more, and really what these are saying is everything that you talked about yesterday, or you read about or watched, you're using that then to prove things. So the alternate interior angles converse says that if these two angles, the alternate interior angles, so 4 and 5 in this picture, are congruent, then lines J and K are parallel. And the same thing, I'm sorry, those were interior, and then the exterior, same thing for exterior. So if 1 and 8 are congruent angles, then line J and line K are parallel. And then the same thing goes for consecutive interior angles, or the other thing that we called these are same side interior. Okay, they mean the same thing. If they are supplementary, so alternate interior, alternate exterior are congruent. Consecutive interior angles have to be supplementary. So when you add them together, 180 degrees. So we're going to look at the information given here and see if there's enough to say that these lines are parallel. So the first one, we have these two angles marked here, and these are corresponding angles. So I would say yes, line M and N are parallel. So M is parallel to N by corresponding angles. Okay, because the corresponding angles are congruent, that means that M and N are parallel. Okay, we're going to look at this. We have M and N cut by transversal R. These two angles, they're vertical angles, but that doesn't tell us anything about line N. And so there's not enough information here because there's nothing told to us about line N and its intersection with the transversal. So this is no, not enough info. Okay, and then here we have lines M, N, and S, and then this transversal R that goes through them. But we have these two angles here marked that they're congruent. And so on this transversal and on lines M and N, those are alternate exterior angles. And so it's because they're on the exterior of those two lines, M and N. So this would be yes, and that's M is parallel to N by alternate interior angles. Okay. All right. So the next thing that we want to do here is just name how these are related. And it's kind of hard to tell which angles we're talking about, but we're talking about this angle here and this angle here. Okay, and so if we have line L and line M, and they're cut by a transversal, and these two angles related to that transversal and those two parallel lines, those are alternate interior angles. Okay, so that's that type of angle. So we've named the angles. Then we want to find the value of x. Okay, so 14 plus 3x equals 5x minus 66. And we can use this equation because we know that L and M are parallel because they're marked that way. And these are alternate interior angles on a set of parallel lines cut by a transversal. So we can set those two angles equal to each other and solve to get the value of x. So we'll take away 3x and then add 66 to both sides and then divide by 2. So the value of x, if these lines are parallel, and that's the value that would make them parallel, is 40. So if you plugged in 40 for x, both those angles should be the same. Okay, you can do the same thing again here. These are inside, so they're interior angles, and they're on the same side of the transversal. And so I would call these same side interior angles. Okay, again, we can call them consecutive interior, and that's fine, but I like to think of them as same side interior because they're on the same side of the transversal and they're interior, and so for me that makes more sense in my head because then I know exactly where those angles are located. And we know that same side interior angles are supplementary. Okay, so that means that we can take 7x minus 8 plus 62, set it equal to 180, and then solve that. So we'll combine like terms, and then subtract 54 from both sides, and then divide by 7, and we get that x is equal to 18. Okay, and so that is the value for x, which would make lines A and B parallel, because that would force those two to be supplementary angles. Okay, for this one, we're just going to set up the equation again, because we're talking more about the relationships. And so first we want to name the angles again. So it's kind of hard to tell, but we're talking about this angle and this angle. Okay, so they're on alternating sides of our transversal, and they're on the exterior, so they're alternate exterior angles. Okay, and we know that alternate exterior angles on a set of parallel lines cut by a transversal are congruent, so we would set up the equation 3x minus 33 equals 2x plus 26, and we could solve that for x, but really the important thing that we're looking at right now is just identifying those relationships between parallel lines cut by a transversal and the angles that are formed. Okay, so here's our next one. If two lines are parallel to the same line, then they're parallel to each other. Okay, so in this diagram here, if P and Q are parallel and R and Q are parallel, then that means that P and R are also parallel, which is pretty intuitive because if two lines aren't touching and then another line is parallel to one of those, it's also not going to touch. Okay, and remember, parallel lines are lines that never intersect. All right, so what we're going to do is use that idea then to help us find the measure of angle 8. And so the first thing is we see, okay, P and Q are parallel. I'm going to mark that. And then Q and R are parallel, which means we can say this R is parallel to P and Q because of the theorem from the last slide. And then we can use that information to say, okay, how is this angle and this angle, how are they related? Okay, so since they P and R are parallel, those are actually same side exterior angles, which have the same relationship as same side interior angles. They are supplementary. So we can say that 115 plus the measure of angle 8 is equal to 180 degrees, and then subtract 115 from both sides, and get that the measure of angle 8 is 65 degrees. Okay? Excuse me. All right, so for this last one, we're going to take those angle relationships and we're going to actually write the proof. Okay, so at this point, I hope we've realized, all of you, when I say we and me, that the givens should always be our first statements. So measure of angle 1 is equal to 115 degrees, and the measure of angle 2 is equal to 65 degrees. Okay, and these first two reasons are going to be given because that is given to us. And then what we're trying to prove is that m is parallel to n. So what I'm going to do is I'm going to label this and say, oh, okay, I know that this is 65 degrees. And I see this is 115 degrees. Oh, I see this relationship. I know they're on the same side of the transversal in between m and n. And so they're same side interior. And I know that if same side interior angles are supplementary, that makes the lines parallel. So what I'm going to do from here is say, I know I want to use that. Somehow I want to use same side interior supplementary to get to the fact that I'm proving that m is parallel to n. Well, first I need to show supplementary. So I need to show this here. 115 plus 65 equals 180, okay, which it does. And this is a reason that we haven't used before and we won't use very often, but we need this piece of information. But this equation actually doesn't tell us a whole heck of a lot about the diagram, about angles. It's just math. It's just saying 115 plus 65 equals 180. And so we actually are just going to use the reason of math here, because that's just a true statement using math and arithmetic that we are familiar with, okay? But then we want to continue to use that and substitute some things in that we do know. So for this, I would say, okay, I know this right here, 115 is the measure of angle 1. And I know right here that 65 is the measure of angle 2. And so I've used substitution to get our new equation there. A measure of angle 1 plus the measure of angle 2 equals 180. And then I can say, oh, I know when two things add up to 180 degrees, they're supplementary angles. That's the definition of supplementary. So I'm going to say angle 1 and angle 2 are supplementary. Okay, and then we have here, this is going to just be the definition of supplementary. Okay, now we can say, oh, that's what we were trying to prove. We knew they were same side interior angles, and we had to say they're supplementary to show that m is parallel to n. So we're going to say m is parallel to n, and that is by same side interior angles. Okay, because we know that if they are supplementary and they're same side interior angles, that makes the two lines parallel. Okay, so that is 3.3. Again, we're just using everything we know about the relationships and angles and parallel lines cut by a transversal to then prove things and solve for x. Please take the time to go back and watch any part of this video that you need to, and please email me with questions.